Working. Sorry. Okay. Thank you. So this is joint work with my supervisor, Francesca, Toni. So today I'm going to present on monotonicity and noise tolerance and case-based reasoning with abstract argumentation. So essentially, what is this? We propose a modeling of a certain kind of classifier has a reasoning system or sort of reasoning system, and we ask whether this classifier is non-monotonic according to a typical non-monotonicity property. It's going to see Cauchy monotonicity. And we apply this to abstract argumentation for case-based reasoning, which is past work, something already in the literature. And we define a more cautiously monotonic variation for this model ACBR. So I'm assuming the background here on abstract argumentation. I have arguments, attacks, and the ground extension. I think I'll skip the background for this audience. What we define here is a classifier. It's a very abstract generalization of a classifier. Has a function that, supposing a set of inputs x and a set with two elements y, we suppose a classifier has something that receives a data set, which is a subset of relations x, y, and receives a new case x, and gives as output a prediction y. So we suppose it has a function. And we define an inference relation on this we say that the data set infers a pair xy if and only if the prediction for x on the classifier trained on a data set D is y. And we say it's not xy if there's another y prime is different than y, such that that's the prediction for x. And we ask whether this relation is Cauchy monotonic for a classifier. So essentially the gist is whether, given a set of assumptions K, if you have a conclusion A and another conclusion B, if you add back A into your premises, whether you keep your conclusion B. So in that sense here would be if you add the prediction back into your original data set or into your case base, whether another case that was predicted is still a conclusion. I'm going to give an idea of what is ACBR. So ACBR uses abstract argumentation to model case-based reasoning in a particular way. I'm going to code this with an example in which I have a very toyish example in which I have two past cases where I'm trying to evaluate whether someone should go to jail, and there are two past cases. One, someone committed a homicide and was guilty, another person committed theft and was guilty. There's this default of presumption of innocence. If there's no information, person should not be guilty. And we are asked whether someone in which we consider two features, homicide and self-defense, whether this person should go to jail. So this is kind of an instantiation, but in general, cases are described as partial orders, here using subsets, but it could be more general than that. And the prediction is the default outcome here minus if and only if the default argument this here is in the ground extension. So attacks go from the past cases to other past cases or to the default case when the case is more specific, from more specific to less specific, and have different outcomes. And finally, new cases attack past cases which are irrelevant, and here that means they have no feature. They're not smaller, so they have a feature that's not in the new case. So the prediction here would be that this case should be guilty because this theft, well, essentially because the default argument is out, it's not in the ground extension, since homicide is in the ground extension and attacks it. Of course, that's not what one would like. So if there is a past case saying, oh, HM and SD, that's innocent, then that would be added to this case base, and that would attack then homicide. And finally, the default argument would be defended and would be in. So the prediction would be minus. So there are two issues with ACBR. The first of all is we can prove that it's not Cauchy monotonic. I'm not going to show the counterexample, but it's in the paper. But we can define a Cauchy monotonic variation of it. There's another issue with ACBR, which is when there are incoherence, that is past cases in which they have the same characterization but opposing outcomes, it may trivialize. So here's an example. So suppose there is a homicide plus and minus. the default case is not, the prediction would be plus because the default case is not in the ground extension, but there's no argument in the ground extension that attacks it. So it's a sort of trivialization, sort of, okay, the outcome is plus, but it's not really intuitive why it should be following this logic of case-based reasoning of a past case that justifies the prediction. So I'm going to show how one can construct a cautiously monotonic variation. And we start with a definition of surprising, which is a case X, a pair XY surprising with respect to a data set when, or a case base, if when we remove it from the data set, it does not predict this pair. So here's an example. And here we're going to consider whether ABC plus is surprising or not. Well, if we remove it and we query for it, so what's the outcome for ABC? You see that outcome is plus. C plus is in the ground extension and it's attacking the default case, but that's already the prediction plus, so ABC plus is not surprising. Okay, so what's interesting about this is that ACBR has this property that the prediction for a new case X depends only on cases on the case base X prime, which are smaller than X. And this is just a way of constructing a variation of ACBR to guarantee cautious monotonicity. So we'll select some cases in the case base and only use those for the inference. So I'm not going to give the general algorithm, but I'm going to illustrate an execution, which is starting from a case base. We sort the case base following the partial order. We topologically sort. It does not really matter when it's not determinate, as long as it respects the partial order. And we start with only the default case in our argumentation framework. So we consider the minimal cases, well, to be analyzed, and those are the minimal ones, and we ask whether they're surprising or not. So since here it's empty, we only have the default, and the default outcome is minus, every prediction is minus, so both this case on top and the one on bottom are surprising, so we add them to the case base. And then we continue. The next ones would be AB minus and CD minus, and again, for each of those, the prediction would be plus due to the other cases we have already added. And then they are surprising, and we add them. Next is ABC plus, and that's the same example as we have just seen. Whether it is surprising or not, let's query for it. We found out that the prediction is plus, therefore it's not surprising, and thus it's not added. And then finally, we consider the last one remaining. Here is an incoherence example to illustrate. So ABCZ plus and minus, let's query for ABCZ. And similar to the last case, we would find out that the prediction is plus, and therefore ABCZ plus is not surprising and ABCZ minus is surprising, and that would leave us with case base like this, and we would use this resulting case base for the inference in next times. So when you consider that ACBR is like this, you use this algorithm for constructing the AF and making the predictions, the result is that it is cautiously monotonic, and the proof is on the paper. So we apply this variation to, we basically do a case study on a very small data set of case-based reasoning for law. It's the US trade secrets domain, has been used before for other case-based reasoning studies. And here cases are described as factors, so features are for and against. And we do a transformation to make this fit into ACBR. So essentially, we transform, we use features, the outcome and the features to construct some artificial new cases, which they model the precedential constraint. So there's a specific way in which the features are used. I'm not going into detail here, I decided to skip this, but the paper has details and also the poster later. But we modeled this using case-based reasoning and say, okay, let's compare the original ACBR with our variation and see if there's any impact. And okay, so let's do this. And it found out that for this small data set, there's really no difference. So in a way, the way the data set is, there's no either incoherence or violation of cautious monotonicity in this. And we speculate whether this means anything for case-based reasoning in law. Should you expect it to be cautiously monotonic or not? We discussed in the paper, we propose that it should be, at least in some sense, because if a lawyer is interacting with a decision maker, like a judge, and this judge is a sort of case-based reasoner, which is coherent with its own decisions, if it's not cautiously monotonic, then the lawyer could ask questions or ask for outcomes for cases in different order, and that would affect the outcomes. So if you ask two different cases, the judge just following its own, let's say, procedure, its own criteria, there would be a difference in what would be the outcomes just by changing the order in which cases are presented, and not by any difference in values or external factor. So to conclude, under some assumptions, we can study a classifier as a reasoning system or has an inference relation. And we can think of classifiers as being cautiously monotonic or not cautiously monotonic. And for the specific case of ACBR, we can define a cautiously monotonic version. Yeah, and we leave for future work a more adequate empirical comparison in larger data sets, or has really a classifier in a more general scenario. Also has a surrogate model for explanation. So we would like to use ACBR for explainability and compare the impact of it being cautious monotonic or not. And of course, a larger case study on specifically the case of legal data, depending on the availability of data. Another lines of works are applying to more types of data. So this has already been done for the regional ACBR by choosing features and also learning the partial order, which is something that has not been done before. And finally, we would like to evaluate the impacts of cautious monotonicity in interactions with users. And that's it. Thank you.